This video is about nuclear energy. The detailed functioning of a nuclear power plant is quite complex. In this video, I will only focus on those features that are part of the IB Physics syllabus. Nuclear power stations are thermal power stations. We learned about thermal power stations in the previous video. The most commonly used nuclear fuel is uranium-235. Nuclear power stations produce energy for consumers through fission. We learned about nuclear fission in subtopic 7.2. In a nuclear power station, the energy released during the fission of uranium-235 is used to boil water and is converted into the internal energy of the steam particles. As we discussed in the previous video, the steam is passed through turbines and electricity is generated through the use of an electrical generator. There are three key nuclear power plant components that you should be familiar with. The first one is the moderator. During fission, high-speed neutrons are released in the nuclear reactor. The role of the moderator is to slow down these fast-moving neutrons. As a result of this process, the kinetic energy of the neutrons is reduced. This is important because slow-moving neutrons are more likely to cause further fission. Therefore, the moderator ensures that fission is maintained in the reactor. Since the role of the moderator is not to absorb but to slow down fast-moving neutrons, moderators are made of materials that are poor absorbers of neutrons. Another important component in nuclear power stations are control rods. Their role is to absorb neutrons. As a result of this process, fewer neutrons are available and fission slows down. Therefore, control rods are used to moderate power output and to stop fission when necessary, for example, in case of an emergency. Logically, control rods are made of materials that are good absorbers of neutrons. The final component that you should be familiar with is the heat exchanger. Its role is to transfer energy from the reactor to the turbines. In a nuclear power station, steam cannot be simply passed from the reactor to the turbines because radioactive material might escape during the process. Therefore, energy transfer is achieved through a closed water system. You might be aware that there is a lot of controversy around the use of nuclear power. The reason for this is that there are several safety issues and risks associated with nuclear power plants. Let's see a few examples. Temperatures and pressure inside the reactor vessel are very high, therefore the reactor vessel is made of thick steel. To ensure that highly dangerous radiation does not escape, the reactor vessel is surrounded by thick concrete. In case of an accident, safety systems ensure that the reactor can be quickly shut down. Radioactive waste produced in nuclear power stations should be safely disposed. Completely safe disposal technologies are still being developed. Finally, once a nuclear power plant comes to the end of its lifetime, it must be safely decommissioned. This process is expensive, and costs should be considered when calculating the price of electricity that is produced in a nuclear power station. This completes our discussion of nuclear energy. In the next video, we'll learn about the pumped storage hydroelectric system.